Hello. Lucas-Milhaupt brings you more than 70 years of experience brazing metals. Today we're seeing manufacturers in the HVAC and refrigeration industries using more all-aluminum components. With this comes the need to join aluminum components to copper. The difference in these base materials' properties, such as melt temperatures, can make joining more difficult. Today we'll discuss alloy options and the proper procedures for joining copper to aluminum. Lucas-Milhaupt offers 3 alloy options for joining aluminum to copper. All of these are part of our Handy 1 flux cord brazing line. Handy 1 consists of a filler metal in a strip form that is rolled around a powdered flux. AL802 has a low melting temperature and is free-flowing. This alloy is preferred for joining single copper to aluminum transition joints. AL822 has a moderate melting temperature and is commonly used for repair. It can be used for joining copper to aluminum joints with larger gaps. AL718 has a higher melting temperature with the best joint quality and good leak tightness. It may be used when high production quantities and tighter process control can be achieved. The advantages of using Handy 1 are, first, no separate flux is required. Second, you achieve consistent alloy and flux application. And third, our non-corrosive fluxes require no cleanup. An example of an all-aluminum component often requiring a transition joint would be an evaporator coil. Other copper to aluminum joints may include line sets and other transition joints. Let's walk through the steps of producing a transition joint. Please note that a joint gap of 3 thousandths to 6 thousandths is preferred. First, clean both copper and aluminum materials to remove any dirt, oil, or other potential contamination. Then, mechanically roughen the outer and inner diameter surfaces. Next, heat the joint area. We're using a methane-oxygen flame. However, acetylene with a proper tip or any fuel gas that can uniformly heat the assembly would also be suitable. A reducing flame is recommended. The flame should be soft enough and large enough to envelop the joint. Heat should be applied starting at the joint line and working up, down, and around both base materials. Your joint orientation having copper on inside or outside may change depending upon the components, and this may affect heating. Please note that a color change will be seen in copper, but not aluminum. Take care not to overheat or melt the aluminum. Depending on the grade of the aluminum base metal, this can happen between 1100 and 1200 degrees Fahrenheit. Step 3 is to apply the Handy 1 alloy to the joint surface to test temperature. If the alloy and flux begins to melt and flow, the assembly is at proper brazing temperature. Next, focus heat to the outside tube to draw the alloy into the interface of the joint. Minimize time and temperature. Overheating can cause erosion and melting of the assembly. Allow the alloy to solidify and cool prior to moving the assembly. Finally, inspect your joint for any gaps or voids. No post-joining cleanup is required. To summarize, when joining aluminum to copper, choose your alloy based on temperature and production requirements. Ensure that the joint gaps are maintained properly as mentioned beforehand. To braze, clean your materials and prepare the surfaces. Then heat the joint area, starting at the joint line. Apply the Handy 1 alloy and continue heating to draw the alloy. Finally, cool and inspect the finished joint. For more information, please visit our website or contact your Lucas-Milhaupt representative. Thank you.